Alright, today we're continuing on with day 6 and doing more solving with logarithmic and exponential equations. So I want you to take this equation 16 plus 0.878 over 26 all to the 3x equals 30 and solve. You're going to be typing this into your calculator, so round to 3 decimal places. So pause the video, unpause when you're ready to check your work. Alright, so the first thing we want to do here is combine what is inside of the parentheses. So I just typed that into my calculator and I rounded it to 4 decimal places in this case. So I got 16.0338 to the 3x equals 30. I chose to take the natural log of both sides. You did not have to do this. You could have changed this into log base 16.0338 of 30 equals 3x. Or you could use common log. Again, as long as you get the right answer in the end, there are many ways in which you can solve this log equation. I chose natural log. Then this allowed me to bring down the exponent of the 3x to the front, so I end up with 3x times the natural log of 16.0338 equals the natural log of 30. Divide both sides by the natural log of 16.0338, so I get 3x equals the natural log of 30 over the natural log of 16.0338, and then divide both sides by 3, and if I type that into my calculator correctly, we end up with x is approximately 0.409. Alright, next one. I want you to solve log base 5 of x plus log base 5 of x plus 4 equals 1. Pause the video and pause when you're ready to check your work. Alright, so remember when solving log equations, it's best to try and combine logs first. So I'm going to combine these two logs here. They are addition with the same base, so I can multiply what I'm taking the log of, and I get log base 5 of x squared plus 4x equals 1. Now that I have a single log on one side and a constant term on the other side, I can turn this into an exponential to get rid of the log. So x squared plus 4x equals 5 to the first power. 5 to the first power is 5. I have a quadratic equation now, so I subtract the 5 over to the left-hand side and set the equation equal to 0. X squared plus 4x minus 5 equals 0. X squared plus 4x minus 5 conveniently factors into x plus 5 times x minus 1. So since that equals 0, and using the zero product property, I set each factor equal to 0, and I end up with x equals negative 5 and x equals positive 1. However, remember with log equations, we have to make sure that we're never taking the log of a negative. So if I plug the negative 5 back in to either of these locations, I end up taking the log of a negative. Therefore, negative 5 is extraneous, so my only answer is x equals 1. Next one. So here, natural log of x plus natural log of x plus 1 equals 1. I want you to solve this equation, and here I want exact answers. So do not type this into your calculator. Pause, unpause when you're ready to check your work. Alright, so this starts off similar to the last one. We're going to first combine the two logs on the left. Because we have addition, we can combine them and multiply what we're taking the log of, and we get the natural log of x squared plus x equals 1. Now, again, next step is the same. Change it into an exponential to get rid of the log. So x squared plus x equals e to the first. Now we end up with a little bit of an issue. Well, it's not really an issue, but it just is a little more challenging than the last problem. We have a quadratic equation again, however, it is clearly not going to factor because the constant term is e. So what I chose to do was complete the square. You could have also brought the e over to the left-hand side of the equation and set it equal to 0 and then use the quadratic formula. However, I'm completing the square. So what I did was I added 1/4 to both sides of the equation. Because that is half of 1 squared. So my middle term is 1, half of that is 1/2, 1/2 squared is 1/4. Add that to both sides. Then the left-hand side of the equation factors into x plus 1/2 quantity squared. The right-hand side stays e plus 1/4. Remember, because I said I want an exact answer, we're not going to type that into our calculator. If we wanted to round to 3 decimal places, we could. Now, when I solve this equation, I end up with x equals negative 1/2 plus or minus the square root of e plus 1/4. Well, we need to check for extraneous solutions again, and I can see that since I have a negative term here, and if I subtract a quantity, that's going to end up with a negative number. Now, that doesn't necessarily mean it's bad, but since I have just the natural log of x, that means I would be taking the natural log of a negative. So I know for sure the negative quantity is extraneous. Now I also do need to check the positive quantity. So I need to check, is negative 1/2 plus the square root of e plus 1/4, is that going to be a positive number or a negative number? If it is a negative number, then that will not work as well because of the natural log of x. In this case it does work, so my answer is going to be x equals negative 1/2 plus the square root of e plus 1/4. Next one, log base 2 of x plus log base 2 of the quantity x plus 2 equals log base 2 of the quantity x plus 6. Pause the video, solve the equation, unpause when you're ready to check your work. Alright, so here again I first combine the logs on the left hand side of the equation. So now I notice this is slightly different than the last two problems. I have a single log on the left, base 2, and a single log on the right, base 2, and nothing else. So because of my properties of logs, remember log base a of x equals log base a of y tells us x has to equal y. So if log base a of x equals log base a of y, then we know x equals y. So in this case I can drop the logs. So I end up with x squared plus 2x equals x plus 6. Just to point out, another thing we could have done here in the red is I could have subtracted log base 2 of x plus 6, get all the logs on one side and combine them as I had on the previous problems. This is a little bit quicker. Now that I don't have the logs, I can combine like terms and I have a quadratic equation again. Conveniently it factors. X squared plus x minus 6 is x plus 3 times x minus 2. Set each factor equal to 0 and solve, and I get x equals negative 3 and x equals positive 2. X equals negative 3 though is going to be an extraneous solution. If I go back up here and plug it into the first or the second log, I end up with the negative value. So that is extraneous. Next one, e to the 2x minus 5 e to the x plus 6 equals 0. Solve. Pause the video, unpause when you're ready to check your work. Maybe not all in that order. You figure it out. Alright, so here the trick is to recognize that e to the 2x minus 5 e to the x plus 6 equals 0. The left hand side is what we call of quadratic form, so this factors. It factors into e to the x minus 3 times e to the x minus 2. So now we can set each factor equal to 0. E to the x minus 3 equals 0 tells me e to the x equals 3, which means x equals the natural log of 3. E to the x minus 2 equals 0 tells me e to the x equals 2, which says x equals the natural log of 2. We could type those into our calculator and round to 3 decimal places. I didn't specify for this problem, so it's just easier to leave it in the exact form. Next one, solve for x. Oh, I'm sorry, one thing real quick back here. Remember, when the original equation starts with exponentials, we don't have to worry about extraneous solutions. Okay, sorry, back to this. Solve this for x. Pause the video, unpause when you're ready to check your work. A hint is you're going to need to factor some stuff. Now pause. Okay, so we can factor out a negative e to the negative x. We can factor out an x as well. That's our greatest common factor. And then we're left with x minus 2. So now if we set each factor equal to 0, negative e to the negative x equals 0, x equals 0, so that's an answer. X minus 2 equals 0, which gives me x equals 2 is an answer. So these two here are going to be my solutions. Over here on the left, negative e to the negative x. Well, I could rewrite that as 1 over e to the x, which I can't solve without getting rid of the e to the x. So if I tried to solve this, I would end up with 1 equals 0. 1 does not equal 0. Another thought process is back up here. If I try to rewrite this as a log, I end up with the natural log of e to the negative x equals the natural log of 0. But I can't take the natural log of 0. So that's another reason why I know it's going to be no solution. So it's not no solution to the entire equation. Your answers are x equals 0 and x equals 2, but the part on the left did not give us a solution. Alright, solve for x. You should have exact answers for this. So z is some constant that you don't know. So solve this for x. Pause the video, unpause when you're ready to check your work. Alright, so what we need to do first here is we need to change this into a log equation. We have two different choices. Well, we have a lot of choices. We have two good choices. So we have what I did here on the left, and we have what I did here on the right. Both of them are equally good. I chose to continue working with what I did on the left, but if you work with what I did on the right, you should end up with the same answer in the end, and the process is basically exactly the same. The solution thought process is the same. The actual exact steps are going to be slightly different because you chose a different log. So what I did, I changed this into 3x minus 5 equals log base 2 of 5 to the zx. I know my 2's and z's look very much alike. That's why the z's all have slashes in them. So now our goal is to isolate the x. So I brought all of the x terms over to one side. First I bring down the exponent here. Bring the x's over to one side, factor out the x, and then divide by 3 minus z log base 2 of 5. So x equals 5 over 3 minus z log base 2 of 5. Last one. So here, the number y of endangered animal species in the world from 1996 through 2009 can be modeled by the equation below, where t represents the year with t equals 6 corresponding to 1996, during which year did the number of endangered animal species reach 923. Pause the video, unpause when you're ready to check your work. Alright, so what we're doing here is we're going to plug in 923 for y, since that represents the number of endangered species, and we're going to solve for t. So I subtract 702, and I get 221 equals 79 natural log of t, divide by 79, and then change both sides to an exponential, in this case base e. So e to the 221 over 79 is approximately 16.403. So now interpret that in the context of the problem. During 2006, the number of endangered species reached 923. That's it for these notes. Enjoy the rest of your evening.